Find the maxima and minima of the following function y is equal to x plus 1 times x minus 2 whole square. Okay, so how do we find? Let us first further solve this. So we have y is equal to, we have x plus 1, and let's expand this. This is a minus b whole square, and it is equal to a square, which is x square plus 2 square, which is 4, minus 2 into a into b, that is 2 into x. So we get 2 into x. That comes out to be, we have x plus 1 times x square plus 4 minus 4x. Further solving this, so y will be equal to, so let's multiply x first. So we have x into x square is x cube, then we have x into 4, which is 4x, then we have x into negative 4x, which is negative 4x square. Then let's multiply by 1, so we have plus 1 into x is x square, then we have 4, then plus into minus is minus 4x. Solving further, so 4x, negative 4x and positive 4x gets cancelled. We are left with x cube minus, so we have negative 4x square plus negative 4x square plus x square, which is negative 3x square plus 4. Okay, so our y is equal to x cube minus 3x square plus 4. Now to find out the local maxima or minima, so first order condition is that slope should be equal to 0. That means dy upon dx should be equal to 0, which implies differentiating this with respect to x. So we have derivative of x cube is 3x square minus 3 2s are 6x, and derivative of a constant is 0, and we set it equal to 0, which implies, let us take x common, so we have x, we are left with 3x minus 2, and it should be equal to, rather 3x minus 6 is equal to 0, which implies either x is equal to 0 or 3x minus 6 is equal to 0, which implies 3x is equal to 6 or x is equal to 2. So we got two critical pointers. This is to say, if we have, since we have the cubic function, so it will look like this. Okay, so we have 2 pointers where slope is equal to 0 at x is equal to 0. Okay, or let me try to show it like this. Let us suppose this is like this. So at x is equal to 0 and when x is equal to 2, we have slope equal to 0. Now since we need to find out which of these two is the minimum point and maximum point. Okay, so when we solve this, we got x is equal to 0 and x is equal to 2. We got two critical points. And let me rub this out. Now second order condition is that we take the second derivative, okay, and evaluate the second derivative at these critical points. So now let's find out d square y upon dx square. So that means the derivative of this function again gives us the second derivative. So derivative of x square is 2x, so 2 into 3 is 6x, 6x minus 6. This is our second derivative. Now we need to evaluate, that is d square y upon dx square at critical points. First at x is equal to 0. Now let's plug x is equal to 0 in this equation. Since this is second derivative, so we have 6 times 0 minus 6, which is equal to negative 6, which is less than 0. If the second derivative is negative, okay, that means we get the, so since we get the second derivative negative, that means it will be a local maximum. So when x is equal to 0, our second derivative is negative. So when x is equal to 0, the function reaches its local maximum. Now let us find out d square y upon dx square at another critical point, that is x is equal to 2, and let us find out what will be our second derivative sign. So we have 6 times the value of x is 2 this time, so we have 6 into 2 minus 6, which is equal to 12, minus 6, which is equal to 6, which is greater than 0. Since when x is equal to 2, second derivative is positive. Second derivative, if it is positive, it is sufficient condition for minimum. So when x is equal to 2, the function is local minimum. So when x is equal to 0, we get the maximum, and when x is equal to 2, we get the minimum. I hope I make myself clear. Thank you.